Hi, good morning, my dear students. I'm Miss Stephanie Kaur. Spark brilliance, inspire life. Copper is everywhere around us, inside our handphone charger, electrical wire, and electronic devices. Copper plays an important role in carrying electricity. This is because copper is one of the best electrical conductor. It is widely used in the modern industry and electrical devices. However, for copper to conduct electricity efficiently, it must be extremely pure. So, how do industry purify the copper? Electrochemistry plays an important role in the purification of metals, especially copper. In this experiment, we will investigate the electrolysis of copper and apply Faraday law to determine the amount of copper deposited during electrolysis. One of the most important industry methods used to purify copper is electrolysis. In electrolysis, the impure copper acts as the anode, the pure copper acts as the cathode, and copper 2 sulphate solutions act as the electrolyte. This removes oxide layer and impurity from copper surface. Dip each electrode into nitric acid solutions to remove remaining grays and oxide layers. Then rinse with distilled water to remove acid residue. Rinse the electrode with acetone. This prevents error during mass measurement. Then the copper plate will dry by hair dryer. Then measure and record the initial mass of both electrodes using a top pen balance. Then we need to prepare electrolyte. Measure the copper sulphate solutions needed by using measuring cylinder. Then pour the solutions into the beaker. Students are usually confused about how to arrange the ammeter, rheostat, and other components in the circuit. Actually, the ammeter and rheostat can be placed in different positions as long as they are connected in series. This is because the current is the same throughout a series circuit. Next, set up the circuit. Before starting electrolysis, can you identify which electrode acts as the anode and which acts as the cathode? The electrode connected to the positive terminal becomes the anode, while the electrode connected to the negative terminal becomes the cathode. So, in an electrolytic cell, the external power supply determines the polarity of the electrodes. The electrode connected to the positive terminal becomes the anode, while the electrode connected to the negative terminal becomes the cathode. Before starting electrolysis, the positions of the electrode must be arranged carefully. Both copper electrodes are immersed into the copper 2 sulphate solutions. One important point is that the electrode must not touch each other. This is because if the electrodes touch directly, electricity will flow through the metal electrodes instead of through the electrolyte solutions. As a result, a short circuit may occur and electrolysis will not proceed properly. Next, the current flowing through the circuit must be adjusted carefully. In this experiment, the electrolysis is carried out using a constant current of approximately 1 ampere. Here, the ammeter is used to measure the current flowing through the circuit. At the beginning, the ammeter reading may not be exactly 1 ampere. Therefore, the rheostat is adjusted slowly until the needle reaches approximately 1 ampere. Normally, after the electrodes are removed from the electrolyte, they should be rinsed and dried immediately to minimize contaminations and obtain more accurate mass measurement. In these demonstrations, the electrodes are briefly placed on a clean white towel so that the changes on the electrode surfaces can be observed more clearly. The white background helps to make the copper deposit more visible. From the observations, the anode appears thinner after electrolysis because copper atoms dissolve into the electrolyte. At the cathode, a reddish-brown layer of copper can be observed on the electrode surface due to the depositions of copper metal. Although the questions only ask for percentage efficiency, percentage purity is also calculated because it is related to the objective of the experiment, which is to study the transfer of purifications of copper during electrolysis. These are the formula used to calculate the percentage purity and percentage efficiency. Percentage purity shows how much copper transferred from the anode is successfully deposited at the cathode. Meanwhile, percentage efficiency compares the experimental result with the theoretical value predicted by Faraday law.